Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 5 from the October 2022 International A-Level Edexcel Pure Mathematics P3 paper. And this question here is about numerical methods and iteration. Here we have a graph that's drawn, and it told us that the profit made by a company, P in $1 million, after T years, T years after the company started trading, is modeled by this equation here. 4t minus 1 over 10 plus 3/4 of ln of t plus 1 over 2t plus 1 squared. The graph of P against T is shown in figure 2. So this is a graph of the model of this function, and according to the model, we want to show that exactly 1 year after it started trading, the company had made a loss of approximately £830,000. Alright, so now, this is the graph of this model. This is the model of the profit made by the company. As we can see, the first few years is making a loss. The profit is negative. And then at a certain point, it breaks even. Profit is 0. And then, according to the model, it will start making profit. So it's going to make a loss first, and then it's going to break even, then it's going to start making a profit after that. Okay, so this is the equation that models this graph. Now, we got to show, according to this model, that exactly 1 year after it started trading, the company had made a loss of approximately £830,000. So basically, all we have to do here is take this equation and replace t with 1 and find what p is, and should come out as negative. And we can then show that this is the profit, or the loss, sorry. So we have 4 times 1 minus 1 over 10 plus 3/4 times the ln of, and you got 1 plus 1, which is 2. I'll just write 2 over, and you have 2 times 1 plus 1, and this is squared. Alright, that's going to give you the profit. Well, that's going to give you P. So that's 4 minus 1, which is 3. So that's 3 over 10 plus 3 over 4 times the ln of, and here you're going to have 2 over, that's going to be 3 squared, which is 9. So yeah. Now, so that gives us a value of, if we calculate that, take our calculator, we have 3 over 10, we have plus 3 over 4 times the ln of 2 over 9. Now that gives us negative 0.82805. Negative 0.82805. It continues on like that. Okay, so now, how is that 830,000? That's what some people might ask. Well, first of all, we're told that this is P pounds in millions. Be careful about that. That's millions. So P is equal to this, right? So we can say that the profit, is equal to negative 0.82805 times 1 million. Because this P is, the P is in millions of pounds. So we got to take this and multiply it by 1 million to give us our answer in pounds. So we take this and we multiply it by 10 to the power of 6, which is a million. And that gives us 828,058 minus 828,058 point whatever. So we get that as our answer, and this is in pounds. So, as it is negative, therefore we can say it's a loss of 800 and we can write it as they asked us. They want it to be basically in two significant figures. So 800 and, if you round it, 830,000. Okay, loss of 830,000 approximately pounds. Okay, so you should put the units and you should make sure that you mention that it's negative, therefore it's a loss. Okay, so that's how you show that exactly 1 year after you started trading, the company made a loss of that much. So there's the answer to part A of this question. Now we're going to move on to part B. It says a manager of the company wants to know the value of T for which the profit is 0. Basically, the time at which it starts to break even, which is going to be over there. They want to know, okay, the value of T for which P equals 0. Show that this value of T occurs in the interval 6, 7. Now, a lot of people, they have an issue with something written in this form. It says interval 6, 7. What does that mean? Many people think it's like a coordinate of a point. No. When it says interval 6, 7, it's just another way of writing inequality. The interval 6, 7, if it says interval 6, 7, what it means is, okay, the value of T is between 6 and 7. That's what it means. It's just an inequality. So basically what they're saying is show that P equals 0 between 6 and 7 for this graph. So let's say this is 6 and this is 7. Somewhere between 6 and 7, the graph passes through the t-axis where P is equal to 0. Okay, we have to show that. We have to show that, you know, P equals 0 somewhere between t equals 6 and t equals 7. That's what this interval notation means. Sometimes it might be given like this, for example, 6, 7, you might have like something like that. What does that mean? That's a curved bracket, that's a square bracket. The curved bracket means you don't include, there's no equal sign for that, right? So that's how you write an interval notation. Okay, so in this case, it means between 6 and 7. Anyway, so how do I show that P equals 0 between 6 and 7? Well, what we can do is we can substitute T as 6 into the equation. If we do that, if what they're saying here is true, if we substitute T equals 6 into the equation, it should give us a value of P which is negative. And when we put T equals 7 in the equation, it should give us a value of P which is positive. Okay, if we can show that the sign of P changed between 6 and 7, that means somewhere between 6 and 7, the line must have passed through the axis where P equals 0, right? So if we can show that there's a change in the sign of P between 6 and 7, we know for sure the graph has passed through the t-axis where P equals 0. So what we need to do is we need to take T equals 6 and put it into this equation. When T equals 6, okay, we've got equation. Let me just put this up here so I can see it better. Okay, when T equals 6, you're going to have P equals 4 times 6 minus 1 over 10 plus 3/4 times the ln of, this is 6 plus 1, which is 7, over, and that's going to be 6 times 2, 12 plus 1, that's 13 squared. 13 squared. If you write that neat, it looks like a 15 there. Don't want to do 8. Okay, 7 over 13 squared, that's 169. Right, so we can find out what P is. So when T equals 6, P is equal to, so we can just stuff that in the equation now. So in a calculator, sorry, we'll have 4 times 6, 24, minus 1, 23, over, 23 over 10. Okay, and plus, we have 3/4 times the ln of 7 over 13 squared. Okay, that gives us negative 0.08799. Negative 0.08799. Yep, okay. And then we can replace the t with 7. Okay, so when t equals 7, you have p equals, you'll have 4 times 7 minus 1 over 10 plus 3/4 times the ln of, okay, what was the formula again? The ln of t plus 1, so 7 plus 1, which is 8, over 2 times 7, which is 14 plus 1, 15 squared. 8 over 15 squared. Okay, so we can say that when t equals 7, p equals, you can put the value in now. Okay, so we'll have here, that's going to be first 15. So change that to a 5, that's 15, and that's going to be an 8. So change that to 8, that's 8 over 15 squared. 3/4 ln is okay, 10 is okay, it's just the top now. That's 4 times 7, which is 28. 4 sevens are 28 minus 1, which is 27. That gives you 27. So you have 27 over 10 plus 3/4 ln of 8 over 15 squared. And that gives us 0.19750. 0.1975. Okay, 19750. 05, whatever. Okay, so that's, we can see here for sure that there's a change in sign. So we don't just leave it like that. A lot of students leave it like that. They show there's a change in sign, but they don't mention any explanation, right? You have to give some sort of explanation in this type of question. So you must say that as in the interval 6, 7, okay, there is a change in sign, okay, for when t equals 6 and t equals 7, okay, change in sign for t equals 6 and t equals 7 in P. And in addition, you have to mention, and also, okay, P is a continuous, or the curve C. They told us about the curve C, right? It's called curve C here. No, I didn't call it curve C. Okay, we can just say the curve. We can just mention the curve is a continuous function. Can't call it C. Also, the curve is a continuous function. Okay, the curve is a continuous function. Therefore, okay, a root must exist in that interval. Okay, so if a root exists in the interval, therefore p equals 0 somewhere in the interval 6, 7. Okay, so we mentioned that as there's a change in sign, so they're looking for this, they're looking for there is a change in sign between t equals 6 and t equals 7. And also that the curve is a continuous function. They're looking for that. Okay, it's a continuous function. Therefore, we can say that there must be a root somewhere between 6 and 7. Okay, there must be a root somewhere between 6 and 7 because of those reasons. You must mention the change in sign, and you must mention continuous function. All right, if you don't mention those, you will not get the full marks for this question. You don't just show that there's a change in sign without mentioning that proves there must be a root. Okay, it's a continuous function, meaning there's no break in it. Why do you have to mention that it's continuous? Well, because if it was a type of function like this where there's an asymptote, there would be a change in sign. Like there would be negative there and it would be positive there. Supposing this is between 6 and 7. Here, say this is 6, this is 7. All right, the signs change. When you put 6 in here, it gives you a negative value. When you put 7 in here, it gives you a positive value, but there's no root between 6 and 7. It doesn't cross the axis. There's an asymptote. That's because it's not continuous. So that's why we should mention it's continuous, so that we know for sure there's a change in sign and it continues all the way between those values. It's joined together. It's not discontinuous. Therefore, it must have passed through the t-axis where p equals 0, somewhere between those two values. So in that interval, there is definitely a root. So in that interval, definitely p equals 0. All right, so that's something we have to understand to get the full marks for the question. All right, we don't want to lose any marks. All right, and then we got to go to part C. It says, show that the equation p equals 0 can be expressed in this form here. So here we have our equation from the beginning part of the question. Now, we got to put p equals 0 first. So first of all, I'm going to take this equation, 4t minus 1 over 10 plus 3 over 4 times the ln of t plus 1 over, in brackets, 2t plus 1 squared equals 0. And I want to rearrange this to make it looks like this t, the subject of the equation. From the way this looks, it looks like this t has been made the subject of the equation. So we got to rearrange it to make that t the subject of the equation. Let me just tidy that up a bit. That's a plus here. All right, so first thing I'm going to do is I'm going to subtract the whole of this expression from both, or this term from both sides of the equation. So I have 4t minus 1 over 10 equals negative 3/4 of the ln of t plus 1 over 2t plus 1 squared. All right, now, what we notice here is that this is like the reciprocal of that. And what we can understand is from our laws of logarithms, okay, if you have minus ln a, it's the same as the ln of 1 over a, the ln of the reciprocal of a. Why? Because this is like ln a to the power of minus 1. It's a power law, which is ln of 1 over a. So I can get rid of this negative sign and write this as, so 4t minus 1 over 10 equals, I can write it as 3/4 times the ln of this all to the power of minus 1, which is the same as its reciprocal. So I can just swap the numerator and the denominator around. Write it as its reciprocal and change that sign. Okay, so now we've got this as our equation. Now I need to get rid of the fraction. I have to make t the subject. So I'm going to multiply by 10, subtract or add 1, and then divide by 4. So let's just do that step by step. And because they say show that, you have to show your answer. You have to give your answer step by step. You can't just like say, oh, therefore now that's the answer. You can't just like go straight from here and then write the answer down, because they already told us the answer. So you should show, you know, in proper steps how we get there. So we got to multiply both sides by 10. If I multiply this both sides by 10, I'll have 30 over 4 times the ln of, and again we have 2t plus 1 all squared over t plus 1. Now I can add 1 to both sides. So I have 4t equals 1 plus, and that 30 over 4 becomes 15 over 2. Okay, times the ln of 2t plus 1 all squared over t plus 1. Now I can just divide everything by 4. And I do that, I think I'm going to get this. Yeah, I have a quarter. I'll have 15 over 8. It'll be exactly what we are asked. Just divide by 4 to get rid of that 4. So you have t equals 1 over 4 plus divide that by 4. You have 15 over 8 times the ln of this as it is, 2t plus 1 in brackets squared over t plus 1. T plus 1. And thus we have now shown what we are asked to show. Okay, so there is the answer to part C of this question. Just rearranging that to make t the subject and just understanding one of the laws of logarithms here to write that as the reciprocal. Okay, then it says part D, it says using the iteration formula, tn plus 1 equals a quarter plus 15 over 8 times the ln of 2t tn plus 1 all squared plus over, tn plus 1 with t1 equals 6. Find the value of t2 and the value of t6, giving your answers to 3 decimal places. We have to use this iteration formula where we substitute the 6 instead of t, and then we substitute whatever comes back out of that back into t. So I find what t2 is by replacing the t with 6 inside this function. And then I find what t3 is, okay, by putting the value of t that came out after putting it back into the equation again. So we're going to substitute these values back into the equation again. And how do we do that in an easy way using our calculator? Well, this is how we do it. I'll show you how to set this up. All right, so first of all, what I'm going to do is I'm going to just write my steps. So I'll say t2 is equal to 1 over 4 plus 15 over 8 times the ln of, and I'm going to put 2 times t1, okay, plus 1 all squared over t1 plus 1. Right, that's what we have to do to find t2. So I'm just going to show that step first. So that means t2 is going to be a quarter plus 15 over 8 times the ln of, and you're going to have here 2 times 6 plus 1 all squared over 6 plus 1. Okay, so therefore T2 equals, I'm just going to write it down, right, after I've shown you what to do. So now, how do we use this iteration formula? What we do is, if on a calculator, the first thing we do is we put the value we have to substitute into it first. Okay, we type that number in and we press equals. That's now the answer in my calculator, right? That's now when I press answer equals, it's going to come out as 6 because that's the last kind of calculation that I put. 6 equals. Now I'm going to type this equation exactly as it looks. I'll put 1 over 4. I'll put plus, then I'll put 15 over 8, and then I'll put ln. Okay, and then my fraction. Then I have 2 in the brackets. 2 times the answer. Okay, so 2 times, that's 2 times 6, because that's answer, plus 1, close the bracket, squared. So that's 2 times 6 plus 1 squared over, they're going to have 6, okay, which is going to be answer, plus 1. Okay, and then I close my big bracket for the ln. So that's 2 times t plus 1 squared over t plus 1. All right, and that will put 6 in the place of answer, because when I set this up, I put 6 equals before I started. That's going to put 6 wherever there's answer in the place here. So I press equals. That gives me 6.21997. 6.21997. So that's equal to 3 decimal places, 6.220. Okay, that's the 3rd decimal place. Okay, so you round that, becomes 2.22 to 6.220. You have to write the 0 there to show that it's to 3SF, or to 3 decimal places. Then T2. Now all I have to do now is press equals. All right, we want to find T6 now, by the way, T6. We've got T2, we want to find T6. So now all I have to do now is press equals. That's going to give me T3. So when I press equals now, right now this is T2. So T3 is going to be what I find when I press this. That's T3. And then this is T4, and this is T5, and this is T6. Okay, so T6 is 6.31415. Okay, so 6.31415. Let's just make sure. 6.31415 goes on like that, yes. So therefore we can say T6 is equal to 6.314. Okay, so there we have T2 and T6. They're asking for T6. So we just jump all the way to T6. So we just put like, that's T2 plus equals again, that's T3 equals again, T4 equals again, T5 equals again, T6. So those are our two values rounded to three decimal places, sorry. Okay, so there's part D, and then it says, hence, according to the model, how many months it takes, find according to the model, sorry, how many months it takes in total from when the company started trading for it to make a profit. So we can say that the time it takes is going to be 6.314, okay, and that is in years. This is years. Okay, we want to find how many months it takes. So months, we're going to do 6.314 times 12. That will tell us how many months we have. So we take this answer that we got last and we multiply by 12. Okay, so that tells us 75.769. 75.769. And this is now months. Okay, so it says find how many months it takes in total from when the company started trading for it to make a profit. So we can say after 76 months, you could say. Yeah, 76 months, it's going to start making a profit. Okay, so we can say after 76 months. Okay, so after 76 months, they're asking for months and not years, right? So we have to be careful to give the answer in terms of months. So after 76 months, it starts making a profit. So that's the answer to this question, and that's the final part of it. So yeah, so this question was all about iteration and numerical methods. Other questions from this P3 paper from October 2022 can be found in the playlist that will appear in this region here. Other questions from this topic of numerical methods from P3 can be found in this playlist in this area. You can subscribe to my channel by clicking on the link in the middle. Thank you for watching and see you soon.